I went Tendermint, IBC, Tendermint, Comet, and now both Comet and IBC. When we speak about our mission, we think about something along the lines of 50 years time frame. In terms of adoption, I think things are starting to move slightly faster now. We are now in a position in which we actually understand what is happening. So we imagine that we should be able, or ideally by the end of 2024, we want to be able to...
Welcome to the Bare Metal Podcast.
Good afternoon, everybody, and thanks for tuning back into the Bare Metal Podcast. Today I've got Adi Seredinschi here with me from Informal Systems. Welcome, Adi.
Hey there, great to be here.
I'm your host, Ship the Code from Rockaway X, here all the time talking about interesting people and projects. So please, Adi, give us an introduction. You're pretty deep in the CometBFT ecosystem. I'm curious to learn how you got there. What's your role?
My role actually evolved a bit throughout the years. I actually started from the IBC side in the Comet ecosystem. In fact, if I'm to go back to the origins, I started from Tendermint. So in 2020, 4 years ago, around October 2019, I joined first, and there was the era of Interchain Foundation, where we were assembling there different researchers and engineers. And then in 2020, Informal was created. So my role officially in the beginning was research and experiments on Tendermint. Then I pivoted into IBC. This year, I pivoted back into Tendermint. That became CometBFT. And since a couple of months ago, I'm again on IBC, but staying also on Comet. So I'm covering both Comet and IBC now. So I went Tendermint, IBC, Tendermint, Comet, and now both Comet and IBC.
And now both. So you're pretty critical to like all the software stack that's uploading lots
I really
of
like
the Cosmos
going
space.
I like going where the interesting problems are. And I'm not afraid of pivoting or kind of learning new stuff. It's always a joy doing that. So yeah.
So let's unpack. You've said a lot of things, and there are some hints that I think topics are going to be really interesting. So let's take them step by step. I think the first one is, think about Informal Systems. I've looked at the webpage, but what's the organization doing in your words? Like what's the mission? Where does it contribute to the ecosystem?
Informal is not very easy to describe, but there is an easy way to describe Informal. It's one of the most ambitious companies in the space, because when we speak about our mission, we think about something along the lines of 50 years time frame, and the mission is about transforming the money on which the organizations today run and the software on which today's organizations run. So those are very high level, very important and very long range impactful mission. So that's probably the best summarized way of describing Informal. We have our hands in different areas, both in Cosmos ecosystem and a bit more broadly than that. It's called Informal Systems because we started from the idea that this new generation of organizations that we're building, they should be correct because they're going to become critical to the well-functioning of everything. So decentralized organizations, if they're going to function well and if they're going to do a better job than, let's say, legacy organizations, they should be probably formally verified. And it started from formal methods. That's why the company is called Informal Systems. But it's more broadly than that. We also had a lot of focus on Rust because of quality concerns and performance concerns. But that's a bit of the part of the origin story with Informal, or at least the name, and what I think is relatively important in understanding the company.
Why do you mention Rust? I mean, is this connected to efforts around formal verification of source code, and you guys were like exploring different ways of maybe rebuilding the stack using different approaches?
I mentioned Rust because it was one of the two pillars when Informal was started. It was started on the pillar of let's use formal methods to prove that systems are correct, and let's use Rust to build more correct systems than what we already have in Go, for instance, or in other languages. So Rust is traditionally considered to have more support to build more, let's say, higher quality systems in general.
Right. I guess I can understand how around memory control, this is sort of by default, let's say more, let's say safer. Did you guys ever build any sort of specifications in like, formal language like TLA plus or some types of logic like that could then be directly applicable to source code?
Yeah, absolutely. We started from there actually. There was around the time when I joined 2019, I think it was when the first time that the Tendermint algorithm was formally specified. Its safety was also verified around that time. And I think slightly later, maybe a year later, there were also efforts in proving the liveness, that the algorithm is live, that it produces blocks. It's not just not doing bad things, but it's also doing good things. So we definitely invested a lot of effort in TLA+. Actually, part of the founding, let's say the founding team or the original members of Informal Systems were people with long history in TLA+. Igor, for instance, Igor Konov, he created him and part of his group. They created Apalache, which is a symbolic model checker for TLA+. We also had Josef Wider, who was a professor in Vienna. He's a lot of expertise in informal methods and TLA+.
Yeah, super interesting. By the way, are those TLA+ descriptions open source? Could I see them somewhere if I wanted to?
Yeah, I think they should be. So there used to be a repository called Tendermint. So it was GitHub in the Tendermint organization. So Tendermint/Tendermint spec, or no, Tendermint organization spec repo. I think those moved into the Tendermint repo, and I think probably today they exist into the CometBFT repo. Yeah.
Okay. I'll try and find it's just as a point of interest. Okay, so that's informal, focusing on formal. Funny. But you also talk about these different names, CometBFT and Tendermint. There's a lot of sort of drama I see on Twitter now between All in Bits and other organizations. And me coming into crypto pretty late, I always see these fights, but I actually don't get these origins, or I don't understand like where any potential sort of friction is coming from. And I do know that Tendermint has had to rename to CometBFT for, I don't even know why, for some purposes. Can you unpack this history? So since you were there at the beginning, tell us what happened starting from the old Tendermint code base, how these things have split, why they've split, and what the status is today.
So Tendermint briefly was caught in time, or caught in the middle between the plans of its original creator, the founder of Tendermint Inc., All in Bits, and the direction in which the ecosystem is going, more broadly speaking. So I gave a presentation about Tendermint and its origins at the Gateway conference in Prague, and I covered this aspect actually. And in my opinion, the origins of the Tendermint repository being frozen. So actually, let me restart. What happened was Tendermint was created at All in Bits. I think that was 2013 when the effort started. Then efforts continued up until probably 2018, when I think I wasn't around, so this is mostly speculation. I think focus started to move towards the SDK. Then after the SDK, focus started to move the IBC. So Tendermint is kind of the oldest part of the stack, and it is the part of the stack that also the Tendermint trademark belonged to All in Bits, versus the IBC trademark does not belong to All in Bits, belongs to, I believe, ICF. And I think the Cosmos trademark also belongs to ICF. So long story short, the creator of Tendermint and the person who owns the trademark decided that Tendermint, the version at which the software existed in late 2022, he decided that we should just timestamp that software. We should say, this is it. It has reached very good maturity, and we should let people use it. And we should not continue pushing it into a certain opinionated direction, such as ABCI++, such as specific encoding formats that were not really agreeing with the original direction of Tendermint. And given that the trademark belonged to All in Bits, and given that the control over the Tendermint GitHub organization also belonged to them, there was nothing we could do. So we couldn't publish anything that was called Tendermint. nor could we actually push any new PRs or actually maintain the software. And actually our whole team, so
this is, you were talking about evolution before, but the policy also applied to like fixes and bug fixes. Like there was just, the idea was, no, this thing is mature now, there are no bugs forever. Okay, that seems excessive, like by any measure, very strange.
Yeah, I think since then Tendermint 2 was created, and that would be the continuation of Tendermint. I'm not sure where that is, but
continue on your original line. So you were talking about Tendermint being frozen and not being evolved in any opinionated directions.
Yes, so that actually happened in December, a few days before Christmas last year. It was when the Tendermint team was essentially kicked out of the GitHub organization, and we had no longer access to push any code there. And then roughly January and February was...
So sorry, just to some degree, apologies again. When you say Tendermint team, you mean the people who are working on Tendermint, not employees of
Exactly. That's a very important clarification, actually.
Okay. So the contributors that were outside the All-in-Bits company, their access was from the repo was removed, so they couldn't actually contribute any more code.
Exactly, yes. Okay. So there was no actually, I'm not aware at that point if there were active contributors from All-in-Bits. The Tendermint core team, by the way, all I'm talking about so far is not the Tendermint algorithm, is the Tendermint core, which is called the Tendermint core because to distinguish from the algorithm, which is just a concept, which is just a theoretical algorithm. So actually the code base is called Tendermint core, but I just use Tendermint for simplicity. So I'm not aware of any All-in-Bits contributions to Tendermint core around that time. And most of the team and the development effort was in Informal Systems at that point. It had been before that in Interchain, a subsidiary of the Interchain Foundation, but it had moved into Informal just a few months before, or half a year before. So maintenance of Tendermint core code was by a team in Informal Systems. And the code existed in the Tendermint GitHub organization, and the GitHub organization was controlled and owned by All-in-Bits. So it's pretty complex relationship structures. Yeah.
Okay, so the decision around like close to that time, I recall that's sort of, I was there when this happened, was to essentially clone the repo, publish it under a new name, and then continue development in the original direction. I guess with the original contributor set is the Tendermint, what you call the Tendermint team, still around?
Yes. So the Tendermint team in the shape of December 2022 is still around. It still exists. It grew a bit since then. The existence of CometBFT is due actually to a large degree of outside forces. It wasn't the Tendermint team in Informal System that decided to do anything. It was actually a confluence of support from application builders, from the SDK team, from the IBC Go team, from ICF, from even previous contributors to Tendermint core that were no longer even in the Cosmos ecosystem, from external organizations that didn't have a stakehold into Cosmos per se, like Anoma, like Celestia. They do have a stakehold, but they're no longer kind of contributors to the SDK directly. Some of these organizations. So Tendermint was actually revived into CometBFT thanks to all of these external contributors. Many of them are names that we all know, and they're active in the ecosystem. And it was decided through this, let's say, emergent situation that, okay, let's continue developing. Let's just give it a new name. The ICF will trademark that name. It's going to be open source. It's going to have all the good things that the SDK and the IBC Go already have. The IBC protocol and the IBC implementations already have. And that's how CometBFT was born late February, it must have been 1st of February, if I recall correctly. It was either beginning of February or end of, I think it was beginning of February. Yeah.
So if you summarize what changes happened for the past year, like sort of when you guys forked from Tendermint and, have the new repo, like what happened these past 12 months? How have you guys used this time? Which features did you focus on?
Since then, there was 2 major releases, CometBFT v034 and CometBFT 035. the most effort by far that the team spent was ensuring that 37 and 38 are correct. And that they behave without impacting the correctness or the performance of networks as a delta to 0.34. So Tendermint was frozen at 0.34. CometBFT was revived or forked out of 0.34. So we first published CometBFT v0.34. And then most of our time was spent in cherry picking code that had been frozen in the old code base in actually abandoned versions, 0.35 and 36. And those cherry picks landed into 37 and 38. And this is important because 37 and 38 are both what collectively became ABCI++. So 0.37 is the first phase of ABCI++, and 38 is the second phase of ABCI++. The code had already been written. So our team didn't actually need to invest a lot of time in the code. There were still some changes that needed to be done, but most of the code had already existed. We just needed to surgically extract with a lot of preciseness the exact pieces that we needed, and then a lot of time was spent was ensuring that we understood that code, that it was safe to deploy, and test it. A lot of tests, a lot of stress tests.
So cherry picking integration of sort of new logic that was forked off or that was branched from the old versions into the new ones. Got it. Okay. Yes. That's of course one of the most dangerous jobs, integrating code that you didn't write or that was written against something else. I understood that it needs a lot of time. I'm curious, just like to interject a technical question. Are 0.34 up to 3.8, are they wire compatible on the P2P protocol level, or have there been changes which render somebody deploying a software with 0.37 on the same P2P net as 0.34 impossible?
So it's a bit more nuanced than that. So there's also a breaking, or could have been a breaking problem between Tendermint 34 and CometBFT 34, because we did do a renaming. So even just that renaming could have been a problem as well. However, our renaming was rather superficial. So we did the renaming of modules and a few other things like strings and constants and things that did not impact the peer-to-peer layer, specifically so that networks can upgrade from Tendermint Core v0.38 to CometBFT 0.38 overnight or fully compatible. From 0.34, CometBFT 0.34 to CometBFT 0.37, there have been changes in the Go API, but not into the messages that peers exchange. There have been changes in the messages that peers exchange, but not in backwards incompatible way. So you can there were additive changes as far as I know, and the same goes between 37 and 38. However, in 38 they were even slightly more major, and in 38 is where the vote extensions were added, and now with vote extensions, peers are going to be communicating a bit more stuff. So vote extensions are an additional type of message, is additive. So it's not breaking in the same way as if the whole protocol would have been broken, but it is.
So these appear on a new channel. Is that would there be a new channel that transports these vote extension messages, or are they on the vote channel?
They're on the vote channel, I think.
Oh, yes. They are on the vote channel. Okay. Yeah. Okay. Yeah, interested to see what happens when more protocol setup is. What is the adoption of newer versions of CometBFT look like? Do you guys have some projects which tend to beta test or run the copies on their testnets faster? Is there are there protocols whose testnets we can see 0.38 on now?
Well, I know the hub team is already starting to adopt 38. I am aware of a couple of other teams. Actually, Marco from the SDK team just mentioned them to me the other day, but I'm blanking on them. I think Noble also is planning to upgrade to 38. I don't think any network is already on 38 because it was just released.
Right. Yeah,
yes,
okay.
yes.
Sure.
So actually, in terms of adoption, I think things are starting to move slightly faster now. There was a period of... So I think Tendermint Core 0.34 was released first time in October or November 2020, I think. And now we're almost in 2024. So it was the same major version Not the major, it was the minor version, but it was considered a major version for a long time. And now finally networks are starting again to experiment and to adopt new things, and that's quite exciting.
Super. So if we look at the new CometBFT's code base, who are the companies you'd put around, let's say, the round table? Who are taking care of this either on a daily or on sort of like let's call it a weekly basis? They're really active in the development. Who are these main bodies that are helping this out?
There are probably 4 that come to mind. But there's a lot more than that help also quite regularly. So the SDK team, Orange Tech signals regularly problems. They do fast tests, I think. Informal and Amulet. So these are the first ones that come off the top of my mind. But there's many other contributors that either give direct contributions, or they help us with insights, with needs, with requirements, with processes, with integration adoption. Among the ones that are most recent, but this is really just the kind of recency bias, Celestia, Chronos, Injective, Numetric. These are some of the teams that we spoke to recently.
If you think about, so you mentioned quite a lot of things are happening. So it feels like the project has enough resources to actually meaningfully develop. Would you say that's a fair statement, that the funding around CometBFT allows it to actually evolve instead of sort of like struggling to fix bugs and maintain security?
It's definitely not an easy answer, and it's not exactly because of funding. I would say CometBFT is probably 6 months to 1 year behind the SDK in the amount of refactoring and velocity that the code base has, or in the amount of dead weight that is pulling down velocity. So funding is not exactly an issue in the sense that simply adding more resources or more capacity or engineering more money to the problem will not necessarily solve it.
Solve the problem. Mm-hmm.
Yeah, it's a sequential process of trying to make the most severe changes that brings the code base in a healthy state. And you cannot rush that. That has been, at least that's my assessment, that it was once rushed in terms of rewriting and more aggressive changes, and it didn't work out well. And the Comet team is both ambitious enough to try to do the kind of changes again, but risk-averse enough to do them at a slow enough pace so that we don't put the ecosystem in danger.
At the risk of maybe looking into too many details, but could you talk about like what major refactoring efforts are necessary to sort of allow for the velocity to increase again?
Yeah, of course. We've been doing them for quite a bit of time. Let's see. There are problems with bandwidth consumption, and the peer-to-peer, the gossip layers of Tendermint have been very poorly specified and misunderstood. We are now in a position in which we actually understand what is happening, and the team has been able to surgically remove things that were unnecessary for the well-functioning of the protocol, and so that it maintains the same guarantees, the same performance, while increasing efficiency. The same happens at the storage layer. At the storage layer, the use or the data footprint of CometBFT-based nodes, it tends to just grow. And it was very complicated to understand what is that due to. Is it because the applications are misconfiguring it? Is it because of the indexer? Is it because of various other subsystems that are not like the writer head log or the consensus that are just mismanaging the software? It's because of libraries, that the pruning mechanism in PebbleDB or RocksDB is just not working well, or the compaction. And it turns out it's something like a combination of all of this. And we're now finally starting to push more major things that are that offer predictability in how fast storage grows over time. Because ideally, when you deploy a CometBFT based node, you should be able to say, I want aggressive pruning. So then the node should grow up to, say, a certain predefined size. But then if pruning works as it should be, then it should not grow based on that.
Right.
So that's what pruning should mean. And we're almost there. Another source of big headaches were the indexer that was tightly coupled with the other subsystems in Comet, in particular with the consensus subsystem, to such a degree that if you just open your CometBFT based nodes to RPC calls, those RPC calls hit the indexer. The indexer puts back pressure into consensus, and then your node falls out of sync with the rest of the network.
So there are actually some like mutual exclusion locks or critical sections where the RPC call will block access to the indexer, and it would be possible to sort of that's essentially a denial of service attack. And that what you're talking about.
Yeah, it can manifest as a denial of service attack. Of course, in our docs and in communications, we often try to recall that. Especially validators should not be opening their RPCs. Of course, not their peer-to-peer ports either. Those are three.
It would be great to get the message out even more strongly. If you actually open the observatory and look at nodes and what ports they have, and we ascribe functionality. I think there are some combos where we see a validator with an RPC port open. Sometimes people say they're proxying the port somewhere else. Mm-hmm. Can't say I'm super convinced that's always the case. But I think it's good to surface this risk and make sure people are diligently closing RPC ports on any nodes that are active in consensus. So in my mind, that actually also involves sentries, right? I mean, if you block both sentries
exactly.
and the validator has a private connection to them, then again, you're not signing blocks. Mm-hmm. So on all the PSA, close RPCs on all sentries and validators.
Good reminder, exactly. So I mentioned three of them. Actually, on the indexer front, one decision there was CometBFT should not be doing indexing in the first place. There's a custom query language implemented in CometBFT. It's a huge dead weight that the team has to maintain. There's no reason. There's so many high performance with SQL or without SQL support kind of databases that Comet should just be able to stream data out of safely without back pressure into consensus. That was manifested into the design that is called the Data Companion API. Very interestingly, we found out that other teams are doing similar approaches. Teams that have pushed the performance of Comet in the past or are already pushing it right now. We heard of similar designs from Newmetric, who were with the Terra team. We heard of similar designs from DYDX, and we were trying to gather feedback from them. Injective also has
maybe Say Network also, I guess.
With Say Network, we speak more about ongoing performance rather than costs and efficiency. Mm-hmm. But with Say Network also, specifically the cold storage front, but that crosses more into the application layer rather than Comet layer. So the Data Companion API has been a huge thing, and I'm definitely missing a couple of other important. Protocol versioning. So currently, in order for Comet developers, and this is the last one, I have maybe a couple of others, but this is probably the last important one. In order for Comet developers to put out new stuff, many interfaces are not even versioned, including the RPC interface. The protos are not versioned, and you cannot do safe upgrades without versioning. So we're now planning to release CometBFT v1. It's essentially 0.38 with a few bandwidth improvements, with the Data Companion API, and with versioning of protos and renaming of protos from Tendermint to CometBFT. So this is a more major change that will likely have some more breaking changes. And this is what V1 will be about. It's nothing critical in terms of consensus refactoring. It's nothing critical in terms of the mempool is all revamped and it's like shining and flying. But it's major changes that we need to do to be able to move faster later on. So we're moving still quite slow. The team feels it. Everyone feels it. There's also an adoption element to it, so we can talk about that as well. But the team feels like we're moving slow, but we do need to move slow in the beginning, do all of these good things.
Faster movement in the future.
Exactly.
Yeah, absolutely makes sense. So like when all these steps are, let's say completed to a degree that allows you to then again focus on more on the future evolution, what's next, right? And you mentioned ABCI++. I guess that work is, you mentioned that's going out in 038. Is that going to get more evolution, or are there new topics, in store in terms of optimizing, I don't know, the flooding protocols or whatever, the flooding strategy for distributing messages or something around this?
We do plan to do more aggressive kind of order of magnitude improvements at the bandwidth efficiency level, so mempool and consensus gossip and so on. That is, we still need to proceed relatively cautiously there because it will require networks coordinated upgrades. It will be a challenge to not break IBC clients, though I think that should be fine. It is not the biggest concern. The biggest concern is just the wire level conversations that happen between nodes, and how do we do it incrementally so that we can fall back on previously correct versions and so on if we discover something. There were attempts to move to libp2p. I don't think those were very fruitful in the past. We could revisit those. I think we do plan to revisit them. We're also looking at other ways of structuring the conversations between nodes, structuring the P2P messages, and introducing new paradigms. Essentially stuff like Narwhal, where there's kind of dependencies between different transactions or between blocks. It allows more efficiency. So bandwidth front is definitely something important we want to look into for the next year. We still want to continue on the storage front because I didn't cover everything, but on the storage front, there's also some dead weights beside the indexer that are also, so now indexer, we're slowly rolling it, we're kind of phasing it out. We're going to mark it as deprecated, but beside the indexer, there's other fronts that we also need to simply cut out. Probably the most important thing that we want to do that is more kind of novel or more, let's say, sexy, is modularizing the consensus engine. So we imagine that we should be able, or ideally by the end of 2024, we want to be able to prove that it's feasible to pull out the Tendermint algorithm from CometBFT and put another one in there, if you so want to, or twist it with certain variations on the Tendermint algorithm. For instance, we're talking about pipelining or pipeline production of blocks. So before you finish producing block 1, you can already start producing block 2 if the mempool is already feeding you with blocks. And that requires pretty severe changes to the consensus subsystem in Comet, and it's not trivial. There's so many Go routines all over the place, and the behavior is poorly understood. So this is probably the most severe internal change that we also expect to have user impact. And then the other things are more experience, like better documentation, better onboarding support. We do plan to continue improving communications. You just mentioned before that we should insist on how operators maybe configure their nodes and what do they do with sentries and so on. We should continue improving the communications there. And there's also something we plan to do on the correctness and QA front. On the correctness front, we may choose to introduce more and more formal models of the different subsystems. I think there's already a formal model of the peer-to-peer algorithm that is currently used, but I'm not sure actually. I think we started it, but we didn't finish it. So we have been experimenting for more than a year now in Informal, not only in Comet, kind of more broadly with this variant of TLA Plus called Quint. Quint is like a developer-friendly TLA Plus. So it actually feels like you're writing code when you write Quint, versus when you write TLA Plus, you're writing. It's closer to it's a model. You're writing a model. So we noticed that if developers write TLA plus ourselves, we tend to write it wrong because we come from the perspective this is a function what I'm writing here, but actually writing models. So Quint is something that is addressing kind of that gap between what you expect to write and what you're actually writing. So it feels a lot more friendly. So we do plan to maybe write more models of the different subsystems and formalize, kind of have formal models of Comet, of the different subsystems in Comet, and prove them, show that they're validly correct, validate them.
This sounds like a lot of exciting stuff that you guys have in store. Formal checks always great. To ensure networks stay up. I think given the number of Cosmos networks in existence and then their continued well-being, I think you guys have been doing a really great job keeping the Cosmos rolled up. So thanks for that, and congrats with that. I guess you guys are around to develop CometBFT to new heights.
Thanks.
So best of luck with that, and I think that's a great place to end. So thanks very much for coming on.
Yeah, my pleasure.
And hope to have you back when you guys have some interesting new developments to hash out what's next.
Yeah, great conversation. Thanks for having me.